Modern day alchemy is alive and well. So much so that about 16% of the entire periodic table is found nowhere in the universe except in our alchemy labs. And yes, we can make gold. It's just not worth it. So there are 19 elements that are synthetic elements. These are the elements that we make in the lab. And depending on the element, they're made in different ways. The lighter of these elements aren't even that hard to make. You can basically make them by accident in, say, a nuclear reactor. But the heavier elements? It takes sophisticated machinery, and it's no walk in the park. To give you a taste of how difficult this is, let's use the heaviest element known to man, oganesson, as our working example. Keep in mind, this element is so hard to synthesize that as of 2020, only 5 atoms of this stuff have ever been produced. And those might be the only 5 to have ever been produced in the entire universe. So how was it made? First, start with the highly radioactive element californium-249. This element is so rare that it's only ever been detected naturally in a single star 356 light-years away. So all of the californium we have on Earth is produced synthetically, about half a gram a year, costing around $185 million per gram. Now, you take 10 milligrams of the stuff, let it oxidize, and use it to coat a sheet of 1.5 micrometer thick titanium foil. Then, take another radioactive substance, calcium-48, and rip off all of the electrons. Then accelerate those calcium ions in a ring until they're going about 10% the speed of light, and then smash them into the titanium foil. Do this with about 5 million trillion calcium ions, and if you're lucky, one of those calcium ions will join with one of the californium atoms and form oganesson-294. As an aside, hopefully it's super clear that making gold this way just wouldn't be feasible whatsoever, even if it is slightly easier than making element 118. Now, the actual merger isn't that complicated. If the 2 atomic nuclei manage to get close enough, then there's a probability that they'll merge. This happens via quantum tunneling because they have to bypass the electric repulsion between the 2 positively charged clumps of protons and neutrons. But if that tunneling does occur, then the energy can be redistributed amongst the constituent particles and the strong force can take over, leading to the formation of a very unstable new element. And then, just like that, it disintegrates about 1 millisecond later. By the way, as a fun fact about oganesson, even though it's in the part of the periodic table where noble gases are supposed to be, it's actually believed that if enough of it formed, it would be both solid and highly radioactive. So neither noble nor gaseous. But that's perhaps a subject for a different video. One of those calcium ions will join with one of those californium